Imagine for a second that you've just spent the last 18 months engineering the most magnificent 10-lane, multi-billion-dollar superhighway.
Right, like an absolute masterpiece of modern infrastructure.
Exactly. The asphalt is perfectly smooth, the lanes are wide, you have the most advanced traffic routing algorithms running under the surface, but there's a massive problem.
The access point.
Yes. The only way for anyone to actually get onto this magnificent highway is by scaling a sheer 80-foot dirt cliff in a 1994 station wagon.
And it genuinely does not matter how optimized those routing algorithms are if no one can actually get their tires on the pavement. I mean, the infrastructure is practically non-existent if the access point is broken.
Welcome to the deep dive. Tonight, we're settling into that smooth late-night radio vibe to talk directly to you. Yeah, you, the software engineer who might be listening to this while staring down a massive, refactored code base.
Or maybe you're just taking a well-deserved walk to clear your head. We've all been there.
For sure. Tonight, we are digging into UX design for artificial intelligence. And our entire mission is exploring that dirt cliff. Because, look, the hard truth of the industry right now is this. You can build a blazing fast, highly accurate, large language model on the back end.
Oh, absolutely. You can fine-tune it perfectly.
But all of that computational power is just completely useless if the front-end user experience is broken.
It really requires a fundamental shift in how we approach product development. Because, as engineers, the natural instinct is to pour all of our energy and computational resources into the model infrastructure.
Oh, 100%. The obsession is always tweaking the parameters, optimizing the context window.
Right, perfecting vector database lookups, trying to reduce server costs. But the actual battleground for adoption is not in the back end. It's the bridge between the machine and the human.
Yeah.
And when that bridge creates friction, the entire application fails, regardless of whatever benchmark scores the model hits in testing.
So let's look at the very beginning of that bridge. Every interaction with an LLM starts with an input. The user has to ask the machine to do something.
Right.
And the most common interface in the world right now for that interaction, the one we see plastered on almost every single new AI tool, is the blank text box. Just the blinking cursor.
Yeah, which is wild because looking through the data on user interaction, the blank text box is actually the absolute worst interface you can build for an AI product.
Wait, really? The worst?
It acts as the ultimate design anti-pattern for this new era of technology because to a developer, a blank text box feels like offering the user infinite possibilities. But to the user, infinite possibilities just feel like an impossible burden.
Okay, wait, I have to push back on that a bit. Because the developer mindset fundamentally loves the blank text box. I mean, think about the Linux command line.
Oh, sure. The ultimate canvas.
Right. You drop a developer in front of a blank terminal, and it's a power tool. You can chain commands, you can pipe outputs, write shell scripts, build entire ecosystems from that one blinking cursor.
Yeah.
So why take that flexibility away? If we're building intelligent applications, shouldn't we give users the maximum amount of freedom to express what they want?
Well, that assumes the user already possesses a mental model of what the system can do. The distinction here is really between a power user and an everyday user.
Okay, makes sense.
For a power user in a Linux terminal, you already know the syntax. You know the boundaries of the file system. You know exactly what grep or awk actually does.
So the flexibility is good because you know the rules.
Exactly. Infinite flexibility is a superpower because your brain has already constrained the possibilities to practical applications. But for the vast majority of everyday users interacting with AI, infinite flexibility just causes absolute paralysis.
Cognitive load.
Right. The cognitive load of having to figure out not just how to structure the prompt, but what the system is even functionally capable of doing. It's just overwhelming. They hit blank page syndrome.
So it's less like handing them a power tool and more like dropping someone who doesn't know how to code in front of Vim and just expecting them to write a web app.
Yeah, they aren't going to feel empowered. They're going to freeze, type hello, get some generic response, and then just churn out of the app entirely.
Wow. So by relying on a blank text box, the application forces the user to do all the heavy lifting of translating their vague, messy human intent into a perfectly structured, context-rich prompt.
Precisely. That is an engineering failure masked as a UX choice. To make AI truly accessible, the interface has to guide the user's hand. It has to abstract the prompt engineering completely away from the user.
And the most effective strategies for this revolve around moving away from the void, right?
Yeah.
Like moving towards structured input.
Yes. Suggested prompts, contextual actions, and progressive disclosure.
Let's break down how you actually implement progressive disclosure in this context, because if you're building a UI, you don't just show the user every possible parameter they could tweak on screen one.
Right. If they're generating a report, you don't ask for the tone, the length, the specific formatting, and the target audience all at once in some massive form.
You start with a simple, high-level intent, like generate a weekly summary.
Yeah.
Then, once they select that, you dynamically load the secondary options. You just reveal the complexity step by step.
And you pair that with contextual actions. This is where the interface anticipates intent based on the user's current state.
Give me an example of that.
So if a user highlights a block of text or a function in their code, the application shouldn't just open a blank chat window asking, what do you want to do with this?
Because the system already knows the context is the highlighted text.
Exactly. It should offer immediate one-click buttons like explain this, refactor this, or find bugs. You eliminate the entire process of the user having to articulate their request. You provide a paved on-ramp to the highway.
Okay, so we guide them. We replace the terrifying void of the text box with smart, state-aware contextual prompts. The user clicks a button, they successfully navigate the input, hit submit, and the request goes over the wire.
And now we enter the waiting game.
Right. The next major hurdle. Because no matter how heavily you optimize your routing, LLMs have inherent processing latency.
Yeah, autoaggressive generation takes time.
The model has to predict token by token. So how do we handle the fact that the backend is fundamentally bottlenecked by this generation process without losing the user's attention?
This is where we see one of the most elegant psychological hacks in modern UX, which is streaming output.
Oh, I love streaming.
It's game-changing.
Yes.
Historically, in traditional web development, you make a REST call, you wait for the server to process the entire payload, and you return a complete JSON response.
But if an LLM takes 8 seconds to generate a comprehensive answer, holding the user hostage with a spinning loading wheel for 8 seconds is just a death sentence for engagement.
Absolutely. So by orchestrating a WebSocket connection or using server-send events, you stream the tokens to the front end exactly as they're generated on the back end.
And the beauty of this approach is that you're exploiting the time to first token, or TTFT.
Right.
The back end might still take 8 seconds to finish the whole thought, but if you can get that first token back to the client in, like 400 milliseconds, you create an incredibly powerful speed illusion.
It entirely rewires the user's perception of latency. I mean, staring at a loading bar for 8 seconds feels like the application is broken. The user's mind wanders, they switch tabs, they lose context.
But if the text starts appearing in 400 milliseconds, they aren't waiting anymore, they're reading.
Exactly. You transform passive, frustrating waiting time into active engagement. And because human reading speed is generally slower than token generation speed, by the time they finish reading the first sentence, the AI has already generated the third.
So from the user's perspective, the system is responding instantaneously, even though the total compute time hasn't changed at all.
It's a brilliant way to respect the user's attention span. But, streaming tokens offers a secondary, perhaps even more critical benefit that goes far beyond just masking latency.
What's that?
It establishes an ongoing control mechanism.
Oh, this is massive. Because if I ask a system to generate a polite email to a client, and I'm forced to wait for the entire batch to process, I might get back a completely unhinged, overly aggressive email 10 seconds later.
And you've wasted time and feel zero control over the process?
Exactly. But with streaming, if the first sentence starts appearing and it says, "Listen here, you absolute disaster of human being," I don't have to wait for the backend to finish drafting that catastrophe.
Right. You can see instantly that the model misunderstood the prompt.
So I just cut it off.
Yes. You provide a stop generating button. The user interrupts the stream, tweaks their parameters, and tries again immediately. This keeps the human firmly in the driver's seat.
It fundamentally shifts the dynamic of the application. The user is no longer submitting a batch job to a mysterious mainframe and praying for a good result.
It becomes a fluid, dynamic collaboration. The machine suggests, the human oversees, and corrections happen in real time.
That real-time collaboration brings up a critical architectural question, though. Because if we've smoothed out the input with contextual actions, and we've hacked the latency with WebSocket streams, where is this interaction actually happening?
The destination problem.
Right. If you're a developer building an AI tool right now, the default instinct is often to build a dedicated destination, like a web app with a chat interface.
Yep, a new tab.
But honestly, if I have to open a new tab, log in, copy my context from my actual workspace, paste it into your chat app, and then wait for an answer, The friction is still too high.
Way too high.
Even a 400 millisecond time to first token feels too slow if I had to spend 30 seconds just getting to the interface.
And that friction is exactly why the concept of ambient intelligence is rapidly becoming the gold standard.
Ambient intelligence.
Yeah. The argument here is that the most successful AI implementations do not treat the AI as a separate destination. They don't force the user to abandon their current flow state just to go converse with a machine.
So they embed the intelligence deeply and silently into the workflows the user is already utilizing.
Exactly.
It makes me think about the difference between a standalone compiler and a real-time linter in your IDE.
Oh, that's a perfect comparison.
If you have to save your file, tab over to a terminal, manually run a build command, wait for it to fail, read the error log, and then tab back just to fix a missing semicolon. That is a destination workflow. It's exhausting.
It breaks your flow entirely.
But a linter is ambient. It lives directly inside your editor. It watches your keystrokes. The moment you miss that semicolon, it quietly underlines the exact line in red. You fix it without ever breaking your train of thought.
That is the exact mental model developers need to adopt for AI. Just consider GitHub Copilot.
Oh, Copilot is a great example.
You are not minimizing your environment, opening a browser, pasting a broken function into a prompt box, and asking for a fix. Copilot is ambient. It's sitting right there in the editor, reading your active file, understanding the surrounding tabs you have open.
And quietly suggesting the next logical block of code in gray text.
Right. If it's right, you hit the tab key. If it's wrong, you just keep typing and it gets out of your way. It surrounds you, ready to assist, without ever demanding you leave your context.
Notion AI does the exact same thing for knowledge workers. You don't leave your document to go brainstorm in a different app. You just hit the spacebar on a new line, and the intelligence is right there.
Fully aware of the entire document's context.
You completely eliminate the friction of context switching. You bring the model to the user, not the user to the model.
But embedding that intelligence so seamlessly introduces a really fascinating paradox.
What's the paradox?
Well, when you execute ambient intelligence perfectly, like when the AI is right there in the workflow, streaming flawlessly formatted text or syntactically perfect code in real time, it feels incredibly polished. And that polish is actually the source of the most dangerous UX trap in artificial intelligence today.
Wait, how does making an application too polished become a danger? I mean, you'd think a seamless, frictionless experience is exactly what we're optimizing for.
It becomes a danger because of overtrust. This is the central challenge of trust calibration.
Overtrust.
Human psychology is deeply susceptible to presentation. When an interface is slick, fast, and streams answers with absolute grammatical perfection and unwavering confidence, we subconsciously equate that confidence with factual accuracy.
Ah, I see. We let our guard down. If the AI sounds like a highly articulate, authoritative senior developer, we just inherently trust it.
Exactly. Even if it's confidently hallucinating a library that doesn't exist, or suggesting an API endpoint that was deprecated 3 years ago.
The slicker the UI, the less critical we become of the payload.
Precisely. If the ambient integration is too perfect, users stop verifying. They just hit the tab key to accept a massive block of code, or they copy an entire generated email, assuming the machine's underlying logic matches its polished presentation.
So the engineering challenge shifts. It's no longer just about making the UI frictionless.
Right. It's about figuring out how to design an interface that is deeply helpful, yet continually reminds the user that they are interacting with a probabilistic engine. A system that predicts the next most likely token, but possesses no actual understanding of truth.
How do you calibrate that trust without ruining the experience then?
The answer lies in feedback loops. You have to build mechanisms into the UI that allow the user to easily signal when the system gets it right, and, more importantly, when it completely fails.
And this is where the front-end UX stops being just a design concern and becomes a critical component of back-end model development.
The feedback loop serves a dual purpose. On the front end, it gives the user a sense of agency. It forces them to pause, evaluate the output, and take action, which naturally helps calibrate their trust.
Makes sense.
But on the back end, that UI interaction is your telemetry pipeline. It's the data source the engineering team desperately needs to understand where the model is hallucinating so they can fine-tune the weights or adjust the retrieval augmented generation pipeline.
Let's get into the weeds on how to actually capture that telemetry, because it is notoriously tricky. We have explicit signals and implicit signals.
Right.
Explicit signals are the obvious ones, the thumbs up or thumbs down buttons next to a chat response, a dedicated regenerate button, or inline correction features where a user literally highlights the AI's output and types the correct code over it.
And that data is incredibly high signal.
But the challenge with explicit feedback is survey fatigue.
Exactly. Very few users are going to proactively click a thumbs up button every time a function completes correctly. They just want to write their code and move on.
Yeah, but they will aggressively hit the thumbs down button when the model breaks their bill.
For sure. So if you only look at explicit telemetry, your data pipeline gets heavily skewed toward the negative. You only see the failures.
That's why implicit signals are so crucial. The backend needs to track behavioral metrics, copy rates, dwell time, insertion events.
Did the user click the copy to clipboard icon? Did they sit on the page reading the output for 30 seconds?
Right. But relying on implicit signals introduces its own massive risk.
Because of the overtrust problem we just discussed.
Exactly. If a user receives a beautifully formatted but factually incorrect code snippet, and they blindly trust it because the UI is so slick, they're going to copy it to their clipboard.
Yeah, and if the engineering team is just looking at a dashboard tracking copy events, they're going to see a successful interaction.
They might even use that interaction to train future iterations of the model.
Which is wild. They're literally training their system to get better at generating convincing hallucinations because they mistook user laziness for a successful resolution.
That is a terrifying telemetry loop.
Which highlights why triangulation is the only viable strategy. You cannot rely on isolated metrics. You have to correlate the implicit signals with subsequent user behavior.
So if a user copies a code snippet, you don't instantly log that as a success.
No, you wait. If they copy the snippet, paste it into their IDE, and then 3 minutes later they return to your application, paste an error log into the prompt, and ask for a fix, you can confidently infer that the initial copied snippet was a failure.
That is brilliant.
Yeah.
You track the state of the workflow over time.
Right. Or if they accept an autocomplete suggestion in Copilot, but then immediately hit backspace 3 times to fix a variable name, you capture that backspace event.
It's an implicit inline correction.
Right.
By designing the telemetry to capture all these subtle, state-aware interactions, you're fundamentally turning your entire user base into a massive, distributed quality assurance team.
Exactly. They're calibrating their own trust through interaction while simultaneously generating the nuanced data set you need to improve the backend model.
The front-end interface and the back-end model weights become inextricably linked. You cannot separate the two. The buttons the user clicks, the delays in their keystrokes, the text they highlight, all of it feeds the engine.
It's a really profound way to look at system architecture.
Let's pull all of these threads together, because if you're the engineer listening to this, actively building in this space, the way you architect your next sprint might need to change.
Definitely.
We started by looking at the input, realizing that we have to kill the blank text box. Infinite flexibility creates infinite anxiety. We need to guide the user with progressive disclosure and contextual, state-aware actions.
Then we examined the processing phase, acknowledging that back-end latency is inevitable. But we learned how to hack the psychology of waiting using WebSocket streams and time-to-first token optimization.
Transforming passive delays into an engaging speed illusion that keeps the user in control.
Then we tackled context switching, moving away from the monolithic destination app and embracing ambient intelligence.
We want to be the real-time linter, not the manual compiler. We embed the AI deeply into the workflows where the user already lives.
And finally, we confronted the double-edged sword of that perfect polish. We recognized that slick interfaces cause overtrust.
And we explored how to build complex, triangulated telemetry pipelines using both explicit and implicit feedback. We use the UI to keep the user critical, while gathering the data necessary to fine-tune the backend.
The overarching thesis tonight is unmistakable. You cannot just take a massively powerful, computationally heavy LLM, bolt it onto a traditional sauce dashboard UI, and expect widespread adoption.
The user experience is not just a wrapper around the AI. The user experience is the AI product.
The bridge is every bit as important as the engine. If the interface fails to translate human intent, the model's capability is just irrelevant.
Well said.
But I do want to leave you with a final architectural puzzle to mull over. Everything we have unpacked in this deep dive centers on reactive AI.
We're designing interfaces and calibrating trust for scenarios where the user actively prompts the machine to do something.
Right. But the entire industry is accelerating toward proactive, autonomous AI agents.
Systems that don't wait for a prompt.
Exactly. Systems that monitor your inbox, draft responses, provision servers, and execute workflows in the background before you even type a single character.
Wow.
So if our greatest challenge right now is managing overtrust and designing feedback loops for reactive systems, how in the world are we going to design interfaces to calibrate trust when the machine starts taking autonomous action?
What does the UI even look like when the AI is the one initiating the workflow?
It completely flips the paradigm.
That is wild. If we thought building an on-ramp for a reactive system was hard, wait until the autonomous fleet starts rerouting traffic while we're still trying to buckle our seatbelts.
It's going to be a wild ride.
To the software engineer listening, as you get back to your IDE or as you finish up your walk, let that question sit with you. The bridge you are architecting today isn't just for handling simple requests. It's laying the groundwork for how humans will oversee autonomous systems tomorrow.
Build it carefully.
Thank you so much for joining us on this late-night deep dive. We will catch you on the next one.